Hi, the Math Dog here. In this video I look at an introduction to transformations, and I'm going to look at specifically dilations, which are stretches or shrinks of figures. So let's get started. So in this video, again, I look at dilations, also called stretches or shrinks. We have officially what we call a pre-image, which is our starting figure, and we do something to the figure and we get an image. So in this case, I'm demonstrating a shrink because we're making the image smaller than the pre-image. So again, pre-image is our starting figure, image is our figure we get when we do something to the pre-image. It's our final figure. In this case here, the image is bigger than the pre-image. But notice the shapes are the same. They may not be the same size, but they're the same shape. Okay. The magnitude or size of the dilation is called the scale factor, or it's often called the scale factor. Scale factor is often represented by the letter K and is a number between 0 and infinity. So K is greater than or equal to 0. So if K equals 0, the image will disappear because you multiply the pre-image by anything on the pre-image by 0, it's 0, so it goes away. If K is between 0 and 1, the image is smaller than the pre-image. So for example, you're going to multiply, take half of something, which is multiplication, you're going to have less than what you started with. So between 0 and 1, the figure actually shrinks. If K equals 1, anything times 1 is itself, so the image is congruent to the pre-image. And if K is greater than 1, and by the way, we'll talk about congruent throughout this. Congruent means same shape and size. So if K equals 1, the image is congruent to the pre-image, it doesn't change. And if K is greater than 1, the image is larger than the pre-image. So like if I multiply by 2, my outcome is twice what I started with. Two figures are said to be congruent if they are the same shape and size. So congruency means same shape and size. So here again, two figures, they're congruent, they're the same shape and size. Two figures are said to be similar if they're the same shape but not necessarily the same size. So here are two figures that are the same shape. The second figure is smaller than the first figure, but they are said to be similar because all the sides actually are in the same ratio or proportion in similarity. So in similarity or similar, pieces, and this you could talk about line segments, pieces are in the same ratio or proportion. Let's just give a quick example of what I mean here. So if this is 4 and this is 2 and this is 2, since these are in the same proportion, I could say, well, what's this missing side have to be here? Let's call it x. The ratio of, we'll call this large to small. The ratio of large to small, which I'll write like this, large to small. Well, this is large to small, so 4 is to 2, as 2 is to x. So I'm going largest to small, 4 is to 2, as 2 is to x. Well, you can cross multiply, you get 4x equals 4. So obviously x has to be 1. So that's what I mean in a similar figure. All the corresponding parts, these are corresponding parts, are in the same ratio of proportion. These are corresponding, and then these are corresponding. Okay, there's 4 basic types of transformations. There's another one sometimes used called a glide reflection, But the glide reflection really is just a combination of a translation and a reflection, so I'm not going to include that here. So a transformation can have multiple steps. For example, you could put together a translation and a dilation to get a composite transformation, but we're just looking at single transformations right now. So the first is the translation, also called a slide. The pre-image and image are congruent. The starting figure and final figure are congruent. You're actually sliding a figure to a different location. That's a translation. A dilation, which is what we're doing in this video. The image and preimage are similar. If the scale factor is 1, then they also are congruent. So in this video, I'm taking stuff and I am either making it, it's going to be the same shape and size, but it could be smaller or it could be bigger, but they're going to be the same shape. So then we have a reflection. Reflection has some reflection line. So if I have a figure here like a triangle that's a certain distance from this line, if I reflect it, it's going to be the same distance. The image figure is going to be the same distance from the line of reflection as the original figure. And then finally we have rotations. So if we start here with the figure, we can rotate it. Usually we do it around the origin, and we get a figure when we rotate it so many, say, degrees. Okay. So now we're doing dilations here. So magnify triangle ABC by a scale factor of k equals 3. Okay, so k equals 3, what I do is I'm gonna start with some points x, y, and I'm gonna multiply each of those points by 3. So this is one way to write it. Then you distribute that 3 to both x and y, or you can also write this as 3x, 3y. Okay, well, before we do anything else now, we need to know the coordinates of these different points. So A, in this diagram, is 0, 2, 0 in the x, and 2 in the y. B is 1 in the x, negative 2 in the y, so that's 1, negative 2. C is negative 3, 1. Alright, so now we'll get to these questions in a moment. But now we're going to use xy becomes 3xy, 3x, 3y like I did up here. Okay, so let's do that in different colors so I can see it. Alright, so A's coordinates were 0, 2. So here 0 times 3 is 0, so that doesn't change, and then 2 times 3 is 6. So A prime is 0, 6. And actually I only have a triangle here, so I don't need point D. I can get rid of that. So B then, the coordinates of B are 1, negative 2. So 3 times 1 is 3. 3 times negative 2 is negative 6. And then C, the coordinates are negative 3, 1. So negative 3 times negative 3 is negative 9. 3 times 1 is 3. So now let's plot the points. So we have A prime, which is the coordinates of A prime are 0, 6. That's A prime. The coordinates of B prime are 3, negative 6. So that's 3 right, 6 down. And the coordinates of C prime are negative 9, 3. So we go 9 left and 3 up. Then we connect the points to get our stretch here, because this is our stretch factor is 3 here, again also called the scale factor. Okay, so there's our dilation there. Now the perimeter is simply is linear because it's just line segments, so the perimeter is going to go up by 3 times. So I'm going to go 3, let's use a color we can see. So it goes up 3 times. Now area though is both in the x direction and the y direction. So in this case I'm increasing the x direction by 3 and the y direction by 3, so it goes up 3, the area actually goes up 3 squared times because it's 2-dimensional, which is 9 times. Okay. Alright, so let's move on to another example. Okay, in this example, we're going to shrink triangle ABC by a scale factor of k equals 1/2, which is 0.5. You could also use 0.5 if you like, because half is equal to 0.5 as a decimal. So in this case, I figure it's going to be smaller than it was originally. The image will be smaller than the pre-image because k is a number between 0 and 1. Anytime you multiply by a number less than 1, I'm talking about positive numbers between 0 and 1, you're going to get a smaller number than you started with. So our rule here is going to be xy becomes 1/2 of xy, or xy becomes 1/2 x, 1/2 y. Same thing. We'll address these in just a moment. So let's label our points now, get the coordinates. So that's -7, 8. Let's check that. So that's -7 left, and that is 6 up. Okay, -7x, 6y. B is going to be 5x, 5 in the x direction, and 8 in the y direction. Okay, then C will be 4 in the x direction, and then -4 in the y direction. So that'll be 4, -4 for the coordinates. Alright, so let's fill those coordinates in now. So A is -7, -7, 6. B is, that should be a parentheses there. B is 5, 8. And C is 4, -4. So our image rule here, to pre-image to image rule, is going to be 1/2 x, 1/2 y. So I take half of -7, that's -3.5, or, okay, which is -7 halves, -3.5. Half of 6 is 3. Half of 5 is 2.5, or 5 halves, or 2.5, and half of 8 is 4. Half of 4 is 2, half of -4 is -2. So let's start with -3/2, 3 for A prime. Should say -3.5, 3. So -3.5 puts me right here, and then it's 3 up, so that puts me right here. That's A prime. So that is -3.5, 3. Okay, B is 2.5, 4. Positive 2.5, 4. So that's 1, 2, 2.5, 4 up puts me right there. So that's B prime. And then C prime is 2, -2. So that's 2 across, 2 down puts me right here. So now I connect those points, and I get my image. So again, how much does the perimeter increase? Actually, it doesn't increase here. I guess in terms of increase, it goes up by half. So it is 1/2 times what it originally was. So if the perimeter was 4 originally, it's going to be 2 now. Now the area is, each dimension is going down by half, so 1/2 of a half is 1/2 times 1/2, which is 1/4. So it's going to be 1/4 times. So the area, if the area of the original figure is 8, the new figure is going to be 2, because the area is 1/4 of the original figure. Okay, so now is a chance for you to practice. So I want you to magnify quadrilateral WXYZ by a scale factor of 2. Stop the video. So we're going to do this a step at a time here. So first thing I want you to do is put the coordinates in for these points, write your scale factor rules 2 different ways, and how much does the perimeter increase and how much does the area increase. So stop the video, answer those questions, and then start again, and we'll go from there. Okay, so the coordinate of x here is 1, 4. Coordinate of y is 0, 1. Coordinate of w is negative 4, 2. And the coordinates of z are 3, negative 5. Okay, so the rule here is we have a scale factor of 2, so we're going to do this way, put 2 times coordinates x, y, or we could write 2x, 2y. So the perimeter is going to increase by 2 times. The area is going to increase 2 times 2 times, which is 4 times. So the image will be 4 times the area of the original pre-image, and the perimeter of the image will be 2 times the length of the pre-image's perimeter. Alright, before I have you get started here on the next part, let's copy these points down. So W is negative 4, 2. X is 1, 4. Y is 0, 1. And Z is 3, negative 5. Okay, so now I want you to stop the video and answer and fill in the information necessary for the image. And again, our scale factor is 2. So stop the video. When you've finished, turn it back on and see if you agree with what I got. Okay, so the rule here is going to be 2x, 2y because our scale factor is 2. So W prime is going to be negative 8. Multiply everything here by 2. So that's going to be 4. That's going to be 2. That's going to be 8. Anything times 0 is 0. That's going to be 2. That's going to be 6. That's going to be negative 10. Okay, so now last thing we're going to do is I'm actually going to copy those coordinates up here so you can see them. W prime is negative 8, 4. X prime is 2, 8. Y prime is 0, 2. And Z prime is 6, negative 10. Alright, so now go back up here and copy. This should copy or put onto the graph W prime, X prime, Y prime, and Z prime, then connect the points. Okay, so stop the video, do that. When you're done, check to see if you agree with what I got. Okay, so let's do this. So W prime is negative 8, 4. X prime is 2, 8. Y prime is 0, 2. And Z prime is 6, negative 10. Alright, so now we connect the points. So this is W prime, this is X prime, this is Y prime in there, and then this is Z prime. Okay, then this concludes this video. So if you found this video informative and you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. You may share the content of this video with others. Thank you very much for watching. Have a good day.